Hi everybody, welcome back to our VANET tutorials. In this tutorial, you're going to learn how to make a new project in OMNET++ and to have Veins and INET be referenced in it. So let's make our new project. To make a new project in OMNET++, you can either right-click and choose New Project, or you can go File, New, and you can choose OMNET++ Project. If you went File, New, and chose Project, you'll end up here in the wizard, and then you can select OMNET++ project. So don't worry if you went the wrong way, you got another choice to make OMNET++. This project we are going to name VANET Tutorials. And as I've said before, I do not like including my projects as part of the workspace because the workspace can get corrupted. Also, this project will be a Git repo. I will have the link to this project in the description so that you can use the Git repository for a point of reference, because we're going to do a little bit of code in here, a little bit of configuration changes, and you might not be able to follow along, and you can just copy it from the Git repo instead. So uncheck use default location, and I'm going to make sure to add it in my VANET tutorial folder. This is the empty folder right now, and this is where my project is going to go. So you can also make a new folder. Make sure support C++ development is checked. So what we want to do is use a template. We want to make an empty project that has a source and simulation folder, and we click finish. So now the VANET tutorial project has been created. And we have our source with its package and the simulations with its package.ned. So this package.ned is giving us that package file path that we would use. In this case, it defaults it to VANET tutorials. You might notice for other packages like Veins, they have a package.ned, and it is the org.car2x.veins. That's actually their website, because the standard way to name a package is to go from least specific to most specific. So you start with the, if it was like a .com, it would be that com dot, then the main domain, and then the subdomain. So this is actually where Veins lives. It lives on veins.car2x.org. So in reverse. We don't really need to do that with our code, but if you wanted to, you're free to set it up to be your website. In our case, we're going to just keep it at VANET tutorials. So now we need to set up our VANET tutorial project to reference INET and Veins. So you can go to the project's properties by right-clicking, going to properties, and we want to go to project references. So we go to our project references and we check INET and Veins. So this means that the project will refer to those packages. But if we want to use paths, we're not done yet. So if we expand OMNET++ and we go to make, we have a setup make options here. So we're going to go to the options, and we go under the compile tab, and we want to include paths, export it from our reference projects. We also are going to include the directories. And in the future, you might use your own project to export paths for other projects, so you might as well check that as well. So this will make it so that you can access the libraries within this project. On the link tab, you want to also make sure to add libraries from other linker options, and this needs to be checked. So check this as well. Another thing that we need to do if you're running OMNET++ 5.3 or above is that there is a new message compiler that has been introduced. And so we have to make sure to tell when we're building this code to use the new message compiler. I'm copying some code from the other side, and this will be available on the Git repo. This is saying that we are setting our MSGC, which is the message compiler, to use version 6. It does not use that version by default, so you have to add this compiler option. Another thing that occurs is there is an interesting issue with Windows. So if you are using a Windows machine, like I am, we need to include some definitions for exporting. So this other sense of code here is checking that if your platform is Win32, then we need to include the WinSock library because it's not available by default for OMNET++ from 5.1 and above. So this is also an important if statement for Windows machines. You won't run into this problem if you're using Linux, so that is one of the many bonuses of Linux. So now we have set up our make rules. Let's apply and close. So let's now test to make sure that we can run INET and Veins from our new project. So I'm going to go under our INET folder and I'm going to copy AODV. So just copying it, and I'm going to add this. This is just the simulation. So we're going to add it to our simulations. We're going to have a little bit of errors because this AODV's NED, their package, it's not in INET examples package anymore. It is now actually in VANET tutorials.simulations and then under AODV. So we need to change it to be that. I'm going to copy VANET tutorials.simulation and change the package here to be VANET tutorials simulations.aodv. And we'll do the same for the small network. We're not going over what NED files are or INIs at the moment. In another video, I explain what they are. So for right now, we're just testing that this works. So what we're going to do is, but you can right click, run as OMNET++ simulation, and we're just going to make sure that this works. So the Qt environment gets launched. We're going to stick with the static configuration and run it. And everything is looking good. So we can set stop and we are done. So we have now ran AODV from our new OMNET++ project, but it's using INET's code. Let's now run the Veins example in our new folder. So Veins, go under examples, and let's copy Veins. We'll paste this here. So again, we need to fix our NED. So this needs the package declaration. So we write package, and then it's our VANET tutorials.simulations.veins, semicolon. Now, in order to run our Veins example, we need to have our Python script launched. Go to your ming.w command line and launch the Python script. So you can see that Sumo has been launched and it's listening on port 9999. Let's run our OMNET++ INI now. So the Qt environment gets launched, and if we run it, I also apparently ran Sumo GUI, so Sumo GUI is launching here, but you can see that we are running our Veins simulation, but from our VANET's tutorial project. So now you have INET and Veins being referred to in your new project. And you're going to say, well, that's good, but I want INET and Veins to work with each other. Well, let's start with the next step. Thankfully, we can use a blueprint. So Veins has some subprojects in it. And within its subproject, it has Veins INET. So we're going to use this Veins INET project as our base for INET and Veins to work together. So let's go down to the Veins INET, expand it. This is the source, and we're going to copy Veins INET here. So we're going to copy it and add it to our source. So paste it here. So again, we're going to have some errors because our packages are not the right name. So we need to fix our package names. So go into your package and fix it to match what your base is. In our case, it's going to be VANET tutorials .veins INET. So that is the package name that is being named here. Now let's update all the other NED files to be referring to the correct package name. We're on the last NED file here, updating this. This also happens to import in the Veins INET application base, so this needs to be changed to VANET tutorials, Veins INET instead. So this gets updated, and now we have updated our NED files. Let's build this code. After building, everything should compile. If you get compilation errors, there are a few areas that you may have missed. So if you get a compilation error and the error says syntax error, unexpected name, well, then you have missed under your properties, under the make, your options, custom, setting up the new message compiler. If it says unexpected name, expected $end, that's what you're missing. If you get something along the lines of you trying to import weird imp underscores, that, if you're on a Windows machine, is related to this error. Outside of that, if you get an error, I will say that there are very interesting bugs that occur solely on Windows. And in that case, what you should do is restart OMNET++, delete the out folder that was created, and recompile again. So again, make sure that we check our make target. It can be a shared library, it can be an executable. Either one is fine. You have all your checkboxes made on compile. On your link, you have checked add libraries, and on your custom, you've included these code fragments so that it's added to your Makefile. So now we have added the INET Veins project to our source folder. Let's use the Veins INET example that is provided to us to test this code. So we're going to grab Veins INET and add it to our simulations. Again, packages need to be updated. VANET tutorials simulation Veins INET, and we are not in the example folder, so we can remove .example. And then our scenarios package also needs to be updated. This refers to NED files that are inside the Veins INET project, so we need to update this to be VANET tutorial. And now it will access the Veins INET car. That's here under source. And this is the Veins INET car. And same thing needs to happen for the Veins INET manager. Okay, so now we have updated our NED files, but we are not ready yet to run our simulation. We need to update our OMNET++ INI file. So our OMNET++ INI file has a reference to the Veins INET sample application for the UDP basic application, and it's not using this anymore. It's going to be using what's in our code base. So this needs to be changed to VANET tutorials, and for our Veins INET car, this also needs to be updated to VANET tutorials. So now our OMNET++ INI file is using the correct locations for what NED files are being referenced. There's one more change we have to make, and that is inside our Veins INET car. So we need to modify the Veins INET car so that it doesn't have the submodule ifconfig. This is just because the Veins INET solution that was written by Veins was for a different version of INET than the INET that we have. We have the latest version of INET. So now this is actually already part of ad hoc host. Specifically, it is already being done within network layer, which causes the IPv4 network layer, and this has its own configurator and does the host auto configuration within that. So we do not need this submodule. So we delete this submodule, save, and now let's run our code. So right click, run. And we're launching up our simulation, and if we hit run, It's actually opening our Sumo GUI still. So this is the actual road that's going on. If you click run, you see the vehicles coming through. There will be multiple vehicles. And then at a certain point, one vehicle is going to transmit an accident to the other vehicles, and you see that they are talking with each other. So now we have Veins moving our cars and working with Sumo, and then our networking being done by INET. So we have now made it so that Veins and INET are working together. The red is a node indicating the accident and sending it, and green means that they received a packet. Now they communicated all with each other, and he received a packet back from him. This is all done within our sample application. So if we exit out of this and we go down to our source, this is the sample application code that is running this situation. And right here it says if the index is 0, meaning that it's vehicle 0, it's going to send a message. So it stops the vehicle, so it's setting the speed to 0. Then it makes a sample message, sets the chunk length, sets the road ID, creates basically the packet, and then at the very end it sends out the packet. So congratulations, you have just learned how to make a new OMNET++ project, have INET and Veins working within it, and have INET and Veins work together. So if you liked what you've seen, please subscribe to my channel. I am going to be putting up more tutorials. My next tutorials will be teaching you specifically what NED and INI files are doing, and we'll also be learning how to make AODV work with Veins, which is one of the standard simulations people use when testing their protocols.